Today we're going to be covering lesson 7-2, which is proving lines are parallel. So what you're going to need today is your Springboard book, open to page 79, something to write with, and your vocab sheet handy. So what we're going to do today is actually proving that lines are parallel, okay, given certain angle relationships. So yesterday we talked about the 3 theorems and postulates about the angle relationships when we have parallel lines cut by a transversal. Okay, so what we're going to do here is they want us to start by stating the converse of each postulate or theorem. Okay, so I went ahead and snipped this from our notes from yesterday. So when we had corresponding angles, we had this theorem. Okay, if lines are parallel, then their corresponding angles are congruent. When we had same side interior angles, we said if their angles or if the lines were parallel, then same side interior angles were supplementary. Remember, same side SS supplementary. Okay. And then when we had alternate interior angles, we could say that if lines were parallel, then we knew their alternate interior angles were congruent. So what they're going to have us do in this number 1 here is write the converse of those statements. So if you remember from the first part of Unit 1, converse of a statement, PQ, is when we just swap the order. So if Q, then P, right? So if I look at, we're going to start with the same side interior angles theorem. So if I look at that one, remember your P is your if statement, okay, your hypothesis. And the Q was our conditional statement, there's our Q, our then statement. Okay, so if we swap the order around for those, then we would have to say something along the lines of, okay, if we have same side interior angles that are supplementary, then the lines are going to be parallel. Okay, so that's the converse. We just reverse the order there. If we have same side interior angles that are supplementary, we can prove that we have parallel lines. Okay, so if I do the same thing with our other 2 theorems or postulates, okay, we would have something like this. I might have to move this out of our way here. That says if we have alternate interior angles that are congruent, then 2 lines are parallel. Okay. And then our corresponding angle postulate says if we're alternate, sorry, we shouldn't have alternate there. If corresponding angles, typo, if corresponding angles are congruent, then 2 lines are parallel. Okay, so this is just the opposite of those theorems that we showed yesterday about our angle relationships. Okay, so again, if we know that there is supplementary, same side, okay, angles, we can prove parallel lines. Similarly with alternate interior angles, if we know they're congruent, we can imply parallel. If we know corresponding angles are congruent, we can imply that they're parallel. So real quick, remember, so lines cut by a transversal, so same side interior would be like angles like those 2. Remember, there's other pairs. I'm just kind of showing one at the moment. If we had alternate interior angles, remember those are on opposite sides of your transversal. They're both interior. And then corresponding angles, congruent, are the angles that kind of match in placement, just on the same side of the transversal. Okay. So we're going to kind of jump ahead here a little bit into page 82. So go ahead and jump to page 82 for me. So we haven't really been doing the springboard aspect of this section so far, but it's kind of set up with Matt. He's designing some strings shown on a graph here. So they're going to tell us that Matt finds that angle 2 is 63 degrees and angle 6 is 65 degrees. So we're going to try and see, does that make our 2 lines here that are through our stakes, okay, are those parallel lines? Well, let's talk about what kind of angles we have for angle 2 and angle 6. So those are on the same side of the transversal, and they're kind of in the same spot on the line, both above, okay, our lines here. So those would be corresponding angles. Well, what do we know about corresponding angles if we have parallel lines? Remember, corresponding angles imply that we have congruence. So if our angles are 63 and 65, do we have parallel lines? Okay, no. Okay, 63 degrees is not congruent or not equal to 65 degrees. Okay, so in this case, you're proving that those lines are not parallel. Okay, so I believe a question on the next page asks, in number 9, how could Matt adjust the strings so that his lines are parallel? So think about that for a second. How could Matt adjust the strings and make his lines parallel? Okay. Well, he could just adjust, okay, to make them both 65 degrees, okay, or both 63 degrees, right? So they could adjust them so that they are congruent after all. Okay. All right, so let's put this in a proof now, our favorite thing to do lately. So we have two lines, M and N, and they're cut by a transversal T. So we have those 8 angles there. So we have that angle 1 is going to be congruent to angle 5. Okay, that's a given. So let's start with that on our proof. That's our given statement. We are now going to have to prove that M is parallel to N, okay? So starting with my given, angle 1 and angle 5, okay, are going to be congruent. So remember, if it's congruent, it implies equal measurements. So that's just our definition of congruence. Okay, so then next we have that measure of angle 1 plus the measure of angle 4 is 180 degrees. And that's the linear pair postulate, which we haven't talked about yet, but your book for some reason decided to throw that in, which that postulate just says if two angles form a linear pair, aka straight line, okay, then they are supplementary. So I just kind of wanted, this is just a little side note here because your book talks about a linear pair postulate without ever really introducing it to us. So I just kind of wanted to put that out there so you guys know what they're talking about when they say linear pair. Basically, linear pair just means two angles form a straight line, then they are supplementary. Okay, so that's what they're saying here. So they're saying angle 1 and angle 4 form a straight line, so they are equal to 180 degrees. So now if I take angle 5 and put that in, so angle 5 plus angle 4 has to equal 180 degrees. And that's because they did a little substitution here. So if angle 1 is equal to angle 5, then you can substitute in for angle 1, you could put angle 5 in its place. So here they're using a substitution. Okay, or if you wanted to, you could also think of that as like transitive property also. But angle 5 and angle 4 then are supplementary. Well, that's just using our definition of supplementary angles. Because if two angles add to 180 degrees, then they're supplementary. So then we proved our statement there because we can say that M is parallel to N because angle 5 and angle 4, if we look at those in our picture, let me erase all this other stuff. Angle 5 and angle 4. Those angles there are same side interior angles, right? So if we have same side interior angles that are supplementary, then we have proven, okay, that we have parallel lines. So again, they're saying the converse of the same side angles theorem. Okay. All right, let's look at this practice. We're just going to do 11, 12, and 13. So these are going to kind of be yes or no answers. So they're going to give you a certain piece of information and ask you, is that enough to know that M is parallel to P? Okay, so they're going to say, given that angle 1 is 52 degrees and angle 7 is 52 degrees, can we use that to prove that angle M is parallel to angle P? So yes or no. Okay. Well, if we look at angle 1 and angle 7, those are actually alternate exterior angles. So alternate angles, if they are congruent, can imply that they are parallel lines. Okay, so those are alternate exterior angles because they're outside of the parallel lines there. But it's the same thing as alternate interior angles. If they are congruent, we can imply that they are parallel. So that was a yes. Okay, so for number 13, let's look at it. So for 13, we have angle 11 is 52. Maybe we'll do a different color. It's kind of hard to see the yellow. And angle 3 is 56. Can we use that to prove that line M is parallel to line N? So look at what 11 and 3, what kind of angles 11 and 3 are. Can we use that to imply that our lines are parallel? So the answer here is no. Okay, angle 11 and angle 3 are alternate interior angles. So in order to be parallel, those have to be congruent. Okay, last one here. Let's look at 14. So 14 says that angle 10 is 124 degrees. 124. And angle 7 is 52 degrees. Can we use that to prove that N is parallel to P? So again, look at angles 10 and 7. If they're marked, you can kind of see them nice there. Can we use those to prove that they are parallel lines? So for 14, we have same side exterior angles. And in order for those to be parallel, then those lines would have to be supplementary. So 124 plus 52, that's only equal to 176 degrees. So this answer, again, is no. If we have same side, again, these are exterior angles, but it's the same rule for if they're interior, they need to be supplementary to prove that we have parallel lines. And these are not supplementary. They add to 176. So that one is no as well. Okay. So again, the big takeaway today is if you can prove those angle relationships that we've been seeing from yesterday's lesson and today's lesson, then you should be able to prove that lines are parallel. Okay, so if you have corresponding congruent angles, if you have same side interior angles that are supplementary, or if you have alternate interior angles that are congruent, then we can imply some kind of parallel lines. Okay. So next lesson, we're going to be talking about perpendicular lines. So stay tuned for that.